This video will deal with just in time. You'll see from this slide it's part 3 of 4. There are 4 videos on this topic, and of course each of them is important and you should consult each and make sure you make notes from each of them. So in this one we want to look at personnel and organizational elements. So workers as assets. Well, it's probably not a nice thing to say about people that they are assets, but we use the word asset here to mean a resource. The workers are a resource of the business. They're a valued resource of the business. Workers, if properly trained with the right competencies and the right skills, they're capable of ensuring that the production system continues, particularly in times when it's under stress or perhaps even in breakdown. So it's important that the workers have the right access to training and be afforded the right training and the right briefing so that they're able to cope with situations which are presumably atypical, particularly in a JIT system. They're able to cope with situations which do not normally arise. So the workers are a valuable asset of the business. The workers should be cross-trained. In other words, they should have several skills. They should be competent in at least perhaps 2 areas or more. Depends on the training and depends on the capacity of the workers and their abilities. But where possible, the workers should have a range of abilities, and these should be cultivated by access to appropriate training courses. The idea is that if some key workers are away from the organization, perhaps away on holiday or away ill, or perhaps have just moved job, have just left the organization, then the remaining staff should be capable of covering that gap. The organization should not be running a risk of failure because a key member of staff has left. So the idea is that remaining staff are able to cover for any gaps that may emerge. They're also, of course, able to help out in the event of a failure in the system, somewhere in the system. The required number of workers or the required number of staff may attend, but they may be able to call for additional support from other members of staff who are, in a sense, not involved in the breakdown, not involved in the situation, but nonetheless are trained and are capable of helping out to more speedily recover the situation and get it back into production. There should be a policy of continuous improvement. It's important that staff are continuously trained, updated, and their skills are tested and improved, and it's an ongoing process, so that in the event of they being required to intervene due to, say, a technical failure in some part of the system, they have up-to-date knowledge of what to do and what is the most efficient means of solution, and they should be able to get the system back online, back running again in an effective and speedy manner. Cost accounting is most important. It's important that there is value for money in the system, and that technology is only implied because it is value for money. But staff should also be implied because they are value for money, and it's an investment that the organization is making in the staff. It's the expectation of management that many of the skills that are trained and are given to the staff will perhaps not be used because the technology is capable of performing those functions more efficiently. But nonetheless, in the event of failure, the staff are available and capable of stepping in. Now, this may only be a small amount of staff who are perhaps there to ensure the technology remains intact and remains running, or it could be staff who will step in to perform particular functions with the product to ensure continuity. It's particularly important if there is a main customer who needs to have a certain quantity delivered in a certain time period. Then in the event of failure in the system and that customer perhaps may not receive the order, if it's a valued customer, then the staff should be available to step in and complete the order, perhaps manually complete the order. But they have got the skills and the abilities to solve the problem, to ensure that the customer receives the product according to the contract and according to what was agreed. Leadership and project management is always an issue within organizations, and it's important that appropriate staff are identified as potential leaders. It's important that personnel should be allowed to demonstrate their competence and their abilities, and there should be a forum or some way in which senior management and line management and perhaps departmental management meet on a regular basis, so that the senior management can see who is interested, who's got the ability, who has got ideas, and who it is that is likely to be a good candidate for promotion in the future. Now, manufacturing planning and control. Well, there should be level loading. In other words, it's important that the machines are balanced out. For example, let's say one machine can make 1,000 items an hour. The next machine can make 500 items an hour. Well, if they're connected, then the first machine will run for an hour and the second machine would have to run for 2 hours. Well, the solution may be to have two machines following on, both of them producing at 500, so that will meet the output from the first machine. But it's important that the machines and the capacities of the machines are also balanced with the likely orders that the company receives. So it's important that careful calculation and careful forethought goes into planning the capacity of the various parts of the organization, and if the product is passed through various processes towards the final product, it's important that all the parts of the organization, all the processes are synchronized and it's balanced throughout. But it's also balanced with the likely demands that the organization is going to receive for the product. There's no point in having machines all balanced and all running very efficiently if the customers don't require that many of the product. So it's an intricate calculation. It's important that the calculation be done, and it's important the whole system is monitored to ensure that it's running smoothly and that all the loads on the machines are balanced so that the machines are running smoothly and at an optimum level, but also that the output at the end is going to customers. It's produced according to customer demand. In other words, the work should be pulled through the system. And JIT is a pull system. The customer requirements is what's pulling the work through the system, pulling it towards the customer. It's not being pushed through the system by management deciding how many to make, and then making so many items and putting them into a store. That's being pushed. But being pulled through the system means it's been pulled by the customer demand right through to the end. So it's a pulled system. I don't need to say too much more about that when I've already explained it, but it is a pulled system, and it's important to see JIT in the context of pulled systems. It's the customer demand, the customer order that is driving the system, that has initiated the system, that brings all of the various processes into play, that occupies the minds of the staff. So it's the customer order that's pulling the work through the system. There should be visual systems. It should be possible to see what's happening, in the sense of there's transparency throughout the system. It ensures all sorts of issues are dealt with. For example, quality is dealt with, and it's possible for staff to sample the quality of the products to make sure that the mechanized parts of the system are running efficiently and smoothly and to the tolerances that are required. But also it should be visual in the sense that if there's the likelihood of a breakdown, it should be obvious to appropriate staff. In other words, it's possible to monitor the system, that there's no part of the system concealed from management that may, in a sense, surprise management by simply breaking down unexpectedly. If there's a breakdown, in a sense, that's the fault of management. They should have anticipated it, they should have seen it, and should have been preventive maintenance in place to cover that. So visual systems enable management to inspect the overall system, and there should be no surprises within the system, so certainly no adverse surprises within the system. There should be a close relationship with the sellers of the products. The customers should be aware of where their order has got to in the system, how long it will be before it's dispatched, any issues that's been encountered. There should be transparency and a good relationship with the vendor. It not only helps in marketing, but it also helps in stopping frustration and annoyance that customers don't know what's happening or when they're likely to receive the product. So it should be good relationships, and there's no obstacle to that, because if the system is properly configured, then the information is available. There's reduced transaction processing. Well, there's less transactions in the system if it's a JIT system. There are less wastage of energy, time, effort, bureaucracy. There's less of it, because the materials arrive from the supplier and go straight into production. They go through the various phases of production, going to the end and to dispatch, and they've been pulled through by the customer order. So it's not as if the products, the raw materials and the semi-completed products arrive in the business and are then put into stores, booked into the stores, and put away in shelves or whatever, and then later on booked out of the stores back into production. So that whole layer has been abolished. But also the whole idea of moving items from one department to the next, and having them signed off and moved out from one department into the next department signs for them, and the previous department issues its notes to the office to say the work has been passed on, and so on and so on. All of that has been reduced. Simply, the item is in production and it goes smoothly through the production system. So there is reduced transaction costs. I talked about preventative maintenance a few moments ago. It's important that the system should be transparent. It should be capable of being monitored by management. Management should be able to see what's happening and understand where problems are likely to arise, because they can see what's happening. They can see components wearing out, or they can see problems in the system. It should be transparent. It should be obvious to the management, and they should be able to take preventative measures before there is a catastrophic breakdown, before there is a breakdown in a part of the system which will hold up the whole system, because the system is interconnected. So it's important to have preventative maintenance. Replace parts even though they've not broken, but they're wearing out. So instead of waiting for the part to give full value for money, but by that time it'll break down. And when it breaks down, it'll break down all parts of the system, all the subsequent parts which are dependent on that part. So having preventative maintenance obviates all of this. It cancels out all of that. We talked about push-pull systems earlier. Well, a pull system, a system for moving work where a workstation pulls output from the preceding station as needed. So it's pulled. In other words, the system pulls out what it requires. It does it, in a sense, automatically. The example here is Kanban. Kanban is the subject matter of a separate video, but it's a system that's widely used to move materials around a business. But with the JIT system, it could be mechanized. It could be simply that the raw materials arrive in, go straight into manufacturing, go straight onto machines. The machines, the output from one set of machines goes straight into another set of machines for subsequent and further processing, and so on until it gets to the finished state. So it's almost a linear system, and that means it's the customer order that's driving the whole thing. They try to see the customer order as pulling the work through the system. All the system is targeting the customer order and completing that customer order. A push system, well, the system for moving work where output is pushed to the next station as it is completed. Push system, sometimes it could be a batch system. The management try to work out what the demand for the product is likely to be. They produce so many of the items so that they can speedily meet orders when they come in, but they meet the orders out of stock, so they're producing for stock. The problem with that is when companies produce for stock, that is dead money. That is capital being tied up. The items produced have all the costs of the raw materials, the processing time, labor, the administration, the overheads. All of those costs are incorporated in the product, and the product now finds its way into the store where it sits idle until a customer comes along and demands it. So in the time between it was produced and the time when the customer placed an order for the product, that time is a waste. And that's the problem with the push system. The pull system, it goes directly to the customer and it goes speedily towards the customer. Let's talk about Kanban for a moment. I mentioned it earlier, the production control system. Well, Kanban is a card or other device that communicates demand for work or materials from the preceding station. So Kanban is just a card, and it communicates a demand for work or materials from the previous preceding station. Kanban is the Japanese word meaning signal or visible record. It's a paperless production system. or control system. The authority to pull or produce comes from a downstream process. In other words, the Kanban is a record kept, let's say, in a container, and the container should have so many items in it. The person who's using it will draw off the container and modify the Kanban card, and when the container is empty, it's replenished. So it's a very simple visual system. It's the subject matter of a separate video, so we're not going to get into detail with it here, but it's important to understand Kanban and understand why it is used so widespread within industry. So a traditional supplier network, well, we have the buyer, and the buyer will have linkages with lots of suppliers. The buyer here could be an organization, could be a company that's buying in raw materials from different suppliers, or buying in components and raw materials from different suppliers. And that's a traditional supplier network. It could be a tiered supplier network where the buyer buys from one supplier, but that supplier buys from other suppliers, and they buy in turn from yet other suppliers. So it's hierarchical in that sense. It's tiers: first tier, second tier, third tier, and so on. So different ways in which the supplier network may be configured. Now let's look at the summary JIT goals and building blocks and see what is it we have discussed. Well, we have the building blocks, we have supporting goals, and the ultimate goal. So the building blocks are the building blocks for JIT, for the just-in-time system. We have the supporting goals, what's going to happen on the way, and the ultimate goal, what is it the business is trying to achieve. So the building blocks could be the product design, we've talked about that, or the process design. We've talked about personnel elements and manufacturing planning. So these are important elements in designing a JIT system and in working out what's required in a JIT system. Now, the supporting goals is to make the system flexible, to eliminate waste, and try to work out where waste is occurring and eliminate it. To minimize inventories. In a strict JIT system there would be no inventories, but we'll settle for minimizing inventories. Eliminate disruptions. So for example, having a policy of preventative maintenance to ensure that any disruptions from breakdown are minimized, or ideally totally eliminated. There should be no disruptions. Work should run continuously and smoothly. And reduce setup and lead times. So reduce the setup times by having machines that are configured and set up once and then allowed to run and feed into the production system. So try to stop trying to switch over machines on a regular basis, because that is a costly exercise, and it's also one that can lead to errors. So these are the supporting goals, and the ultimate goal is to have a balanced, rapid flow of production through the system. That's the goal of JIT, to have a balanced and rapid flow of goods. So there is efficiency, and waste has been eliminated, inventories are minimized, there's no disruptions, setups are few and far between, and the system is quite flexible as well. It can be switched over if need be to doing other jobs. And it's a rapid system. It's one that is very efficient. So these are the essential blocks in a JIT system. And that concludes this video. video. So let's leave it at that and say thank you for watching.